Hello everyone. My name is Riya Ramatri and today's topic is TCP/IP model. Let's dive in. So, TCP/IP model was designed and developed by the Department of Defense in 1960s. It is based on standard protocols of networking. Okay, and TCP/IP stands for Transmission Control Protocol slash Internet Protocol. And this model is a smaller, concise version of OSI model. OSI model has 7 layers, whereas this has only 4 layers. In the picture, as you can see, computer A wants to send data to computer B. So according to sender's end, the sequence of layers are application layer, transport layer, internet layer, and then network access layer. Okay. So first layer is application layer. Application layer is the highest layer in TCP model. Okay, it provides with interfaces and protocols needed by the user. And when you combine the functionalities of session layer, presentation layer, and application layer of OSI model, you get the functionalities of application layer in TCP/IP model. Okay, the main functionalities of application layer are it facilitates the user to use the services of network first. Second, it is used to develop network based application. Okay, and then it provides user services like user login, naming network devices, and formatting messages, emails, transfer of files, etc. And yes, it is the most important one. It provides the function of error handling and recovery of message. Okay. These are some protocols that the application layer has. Okay, there are a lot of them. I have listed the main few of them. First is HTTP. So it defines how hypermedia messages are formatted and transmitted. Okay, next is file transfer protocol. As the name suggests, it is the protocol is laid how the files will be transferred from client to the server. Okay, over the same network. Next is simple mail transfer protocol, SMTP. Now it what does it do? It lays down rules on how the sending and receiving of electronic emails is to be done. Okay, next is domain name system. As the name suggests, naming. uh, it is a naming system for devices in networking. Okay, in the same network. Next is telnet. Telnet provides bidirectional text-oriented service. Okay. Next is Simple Network Management Protocol (SNMP). It is used for managing, monitoring, and monitoring the network, and for organizing information about network devices. Next layer is transport layer. Now this layer is similar to the transport layer in OSI models. The functionalities are similar. Okay, what are it provides end-to-end communication and also error-free delivery of data. Okay, it shields the upper layer of the applications from the complexities of data. Now some functions are reliable data transfer. Okay, so this means that the transport layer it ensures that the data is transferred reliably, okay, between both the host, the sender and the receiver, by using some techniques of like error correction or flow control. Okay, suppose a packet, okay, that you have to send from A to B and it is lost, so it can request for the retransmission of that same packet. Okay, or to ensure that the data is correctly uh, error free, we learned here error free delivery of data, so the correct data is sent there, reliable data of transfer. Next is segmentation assembly. Okay, what does this mean? The transport layer is responsible for breaking up large packets into small segments, large blocks of data into smaller segments that are transmitted over the network. Okay. Next is the reassembly. Yeah, reassembly happens on the receiver's transport layer. How does it happen? Like in the sender's end, block of data is divided into segments. There, the segments are again joined together into the same block of data. Okay. Next is multiplexing and deplexing. Okay, demultiplexing. I'm sorry. Yeah. So the transport layer is responsible for multiplexing the data on the uh, sender's end, and then demultiplexing it at the receiver's end. End-to-end communication. The this layer is this provides a connection-oriented service. Okay, what does this means? It allows the host, both the sender and receiver, both the hosts, to communicate with each other end to end, okay, without the need of any intermediate devices. Okay. Now, what is the working of transport layer? We'll understand that. If a user wants to send data from A to B, two machines are there, A and B, A to B. So over the same network. Okay, so A is our sender and B is our receiver. So A will break the block of data into smaller segments. It will add error correction and flow control information, and then it will then transmit the data in onto the network. Now the transport layer on the receiver will receive the segments. It will check for errors and then collect the segments into the block of code. Okay, all the functions are performed included in this example. Next, two main protocols of this present in this layer are transmission control protocol TCP and user datagram protocol UDP. Now TCP is connection oriented protocol and UDP is connection less protocol. Okay, so because it is connection oriented TCP, it provides reliable and error-free connection communication between end systems. Okay, and it performs sequencing and segmentation of data. Next is acknowledgement feature, and it also gives acknowledgement features and the data flow control. It also controls the flow of data. It is considered to be very effective. Okay. Next, UDP. When you think of a cost-effective method, okay, we always opt for UDP. It is a go-to protocol if your application does not require reliable transport. Okay, it is not as reliable as the TCP is, and these are some protocols in UDP: HTTP, HTTPS, SSH, NTP. Okay. Yeah. Third layer is internet layer. So the functions of network layer in OSI model is same as internet layer in TCP/IP module. Okay. It defines the protocols which are responsible for logical transmission of data over the entire network. Okay. The main protocols are IP, ICMP, ARP. Okay. Now, the main functionalities of this layer are: it is responsible for routing packets of data from one device to another. Now, when it has when a device has to send a packet, okay, so what will it do? It will check the routing table, and after checking the routing table, it will see which is the best possible way that this for a packet to be sent. Okay, in this example I've explained the same thing. Okay, now in this example we have talked about a email. Now email, when you click the send button, you've typed the email. Now when you click the send button, the email is broken down into smaller packets of data. Okay, and then that packets are sent to the internet layer for routing. Internet layer, what does it do? It assigns IP address to each packet. Okay, IP address of a source and destination. Now the packet is then forwarded to the next hop. Hop means, suppose there are two intermediate routers between the sender and receiver. So from sender it will hop to one router, router 1, then to router 2, and then to the receiver. Okay, so this way the hops happen, and router 1 will see that okay, the destination IP address of the destination is not his, so what will he'll forward it to router 2. Router 2 will also see that it's not his, he'll forward it to the destination. Okay, which route is to be followed, that the sender will refer to the routing table to decide which route is to be followed. Next is fourth and last layer is network access layer. This layer corresponds to the data link layer and physical layer in the OSI model. Okay, now network access layer is mainly responsible for hardware addressing, and the protocols present in the layer allows for the physical transmission of data. Okay, now the network layer is the network access layer is a layer in the OSI model that is responsible for establishing a connection between a device and physical network. In OSI model, network layer, what does it do? It was responsible for establishing a connection between device and physical network. Here it is responsible for transmitting and receiving data over physical medium, such as wire or wireless connection. The main functionalities are, it is used in mainly two places, two devices, in networking devices such as routers and switches, and in communication devices such as phones and laptops. Okay. These are the differences, main differences are laid out here between TCP/IP model and OSI model. Okay, now the abbreviation is obviously different. TCP, as we have discussed, OSI has 7 layers, TCP/IP has 4 layers. Okay, TCP/IP is more reliable, and OSI model is comparatively less reliable. Okay, TCP/IP does not have strict boundaries. OSI has very strict boundaries. Now, TCP/IP follows a horizontal approach, and OSI follows a vertical approach. Okay. Now, TCP/IP uses both session and presentation layer in the application itself. It does not have a separate session layer, whereas OSI has separate layers. It has a separate session layer, separate presentation layer, and application layer. 3 different layers. And yeah, these are the basic laid out differences. Thank you.